Today is section 3.1, and here is interesting. I keep saying that this is a giant leap. This is going to be something new. That's because every class is another giant leap. So last time the giant leap we made is the idea of arguments. We introduced arguments, and arguments are the way that you go from the truth of premises to the truth of conclusions. And that's the whole thing about math, right? We have our whole web of, like, you have truths down here, and you connect it to this truth and that statement, that statement. You connect all these statements. You do that through arguments. Here's the problem. And I'll write down section 2.3. Or 3.1, I mean. This is the whole thing. Here's the problem with that. So far, we cannot make implications about things that are not, or implications, meaning we also can't make arguments, I should say. Implications, arguments, all that, about things that are not definite statements. And here's what I mean by that. So far, we can say things like 2 is even implies 3 is odd, right? We can say that. This is totally fine. Makes sense. With current machinery, I'll say. However, we can't say that if x is even, then x plus 1 is odd. Why can't we say that?
Don't know what x is.
We don't know what x is. X is even is not a statement. Remember, and this works because we have statement implies statement, right? We can do statement implies statement, but x is even, this is not a statement. Not statement, not statement. However, this is really what we care about doing with if statements, right? With if statements in regular life, when we talk about math and things like that, what we really want to do is say, like, if x is any even number, then x plus 1 is going to be an odd number. It doesn't really help us to say that if 2 is even, then 3 is odd, because that would mean that okay, for every number, we have to have a different implication. If 4 is even, then 5 is odd. If 6 is even, 7 is odd. Capturing what's trying to be communicated here can't be done with this if then. And that's a big bummer, because this was great, because arguments, we could connect things, right? But something like this statement is a statement we really want to make. For example, I mean, you know, in calculus, like you have statements saying, like, the derivative, or let's say, like, if f is a power function, meaning like x squared, x cubed, whatever, or maybe I should say, if f of x equals x to the n, then f prime of x is going to equal n x to the n minus 1, with the caveat of 1 over x, of course. But anyway, or to the 0, of course. But anyway, the point is, this isn't really an implication as we know it, right? Because is this a statement?
No, because we don't know what x is here either.
You know, actually, x is okay here, because f of x equaling x to the n, the x here just corresponds to things you plug into the function. The issue here is the n. We don't know what n is. Saying that f of x squared equals 2x, that's totally fine. We'll go over functions later. You guys have to know this. But this is just a function. So we're saying if we have this function, then its derivative will be this. But what we can't say is that for this general function where n is just some number, we get this, because what's n? This isn't a statement until we know what n is. It's a whole thing. Anyway, I was just using that calculus example to show you how it's important that we figure this out. And so the way we're going to figure it out is using something called predicates. So I'll say predicates, and they do relate to whatever the heck predicates mean in English class, but I became a mathematician for a reason. I forget what that means. But anyway, they are exactly what that is. And so let's do some examples. Does anyone remember what predicates mean in English? There's like indirect objects, direct objects, subjects. I don't know what it all means. Anyway, though, so we have predicates. Here's the example of a predicate. X is even. There's one. We also have, and hey, you know what? I'll label these so we have them for later. So I'll say example. We have, I'll call this P of X is equivalent to X is even. And then we can have Q of A, B, for example. That means A is B's parent. Or we could have the predicate R of Z, which means I have at least Z hats. And let's do one more, or do a couple more. We'll do S of C is equivalent to C drives a Kia Soul. And we'll do M of D is equivalent to D squared plus 2 equals 6. These are all predicates. And I haven't told you what a predicate is, but let's talk about this. What does, well, let's start over for a second. When I was saying that, like, the if X is even, then X plus 1 is odd thing, the problem with that, X is even, X plus 1 is odd, are in statements. And all of our logic works on statements. So the question really is, what we're trying to do is be able to turn X is even, X plus 1 is odd, kind of into a statement somehow. And so this is where we're going to start. That's our goal. Here's where we're going to start. How do these things relate to statements?
Are these like presumptions about statements that we can make?
Presumption.
Like prerequisites, I guess, before we like define an argument?
I think I see a little bit of, I think I maybe understand what you're saying. But here's what I'm getting at. P of X, or this X is even is not a statement, right? But what could we do to make this a statement?
Do we have to plug in something for X?
I literally have plugins in there for X on my notes here. Stop it. Exactly. We did not play this beforehand. Yes, predicates are sentences. What did I say exactly? Or I'll say a predicate wow, you think you could underline better. There we go. A predicate is a sentence that with finitely many variables that becomes a statement when we plug in subjects for the variables. That's the definition. And let's just look at these examples, see how it makes sense. Right? X is even, that's not a statement. Right? P of X on its own is not a statement. But if you plug anything into it, it becomes a statement. So for example, right? For example, P of 2 is equivalent to 2 is even. Is that a statement?
Yeah.
Yeah, 2 is even a statement. It's true. 2 is even. A statement is a sentence that's true or false. So no, so and we can do that one, right? Let's do Q of Brady Gronk. That's equivalent to saying, so you plug in Brady for A and Gronk for B, you get that Brady is Gronk's parent. Is that a statement?
Yeah.
Yeah. This one's false. No matter how much Brady acts like Gronk's dad, he's not his biological father, right? The point is that notice for all of these things right here, we can keep going, right? Like R of, someone name a number. How many hats do you think I have?
9.
R of 9 is saying I have at least 9 hats, which, if we count, let's see, oh, what's that? Like 1, 2, 3, 4, 5, 6, 7, 8. Oh, I have 9 exactly. So I do have at least 9 hats. Good job. So this is true. I don't know what it means.
Professor, I check our windows and make sure there's nobody there looking and counting.
It's a good point. I do keep my window open, so there's free discrete math lectures happening in my apartment. But anyway, so that's true. I have at least 9 hats. And we can go S of, let's say, a giant hamster. This is saying a giant hamster drives a Kia Soul, and that's true based on those commercials from like 2009 or whatever. So the point is, all of these become statements when we plug in something. Does that make sense? I dropped the marker. I'll be back. And I'm back. So yeah, so all these things become a statement when you plug in something. I think that's nice and simple, right? I mean, these are basically kind of like logic functions, right? I mean, because if you have the function like f of x, if you have the function like f of x equals, I don't know, x cubed, right? X cubed is not a number, but if you plug anything to f, like you plug in 1 to f, you get 1 cubed, which equals 1, you get a number. So it's like a function, it's not a number until you plug something in. A predicate's not a statement until you plug something in. More of that arithmetic, logic, analogies going on here. Anyway, we good on this.